Okay, here we go. We are going to find the derivative using the definition of a derivative. Now, like I'd mentioned, okay, you're going to be calculating hundreds and hundreds of derivatives over the next few months. Most of those you're going to do using shortcut formulas. In this particular example that I have here, I can get the derivative using a shortcut within 2 seconds. But it's something that we're going to do a little later. We're going to take care of this longer, more painful derivative formula first. We're just going to rip off of that Band-Aid, and then we'll do some of the easier stuff after. Okay, so this formula, of course, involves limits. You have to make sure you use the same limit notation that you learned in 12b, where you keep writing limit until the point where you plug in the number. And you could start by trying to plug in the 0 for h right away, but you'll always be dividing by 0, and that would happen for every single example, so there's really no reason to try that. Okay, you're going to get an undefined answer each time. So you actually have to work this stuff out. Okay, so but once again, okay, you only have to use this longer method when the question specifically uses the word definition. So if it said find f prime of x, and that was it, then you could use shortcut formulas. If it said find the derivative, you could use a shortcut. Because you see this word definition, we're stuck using the formula, and we're going to do it. Let's do this right now. Okay, we can find the derivative, writing limit h approaches 0, of course. Nothing really to plug in for h on the denominator. Okay, that's just an h. It's really the numerator, the f of x plus h minus f of x. We're going to figure out what each of those things are. So what I'm going to do is I'm going to put my first thing, f of x plus h, in one set of brackets. And then I'm going to put my second thing, f of x, in another set of brackets. They don't have to be square. It just happened to, there's going to be other brackets inside of here, so I just want to differentiate those. And away we go. So what I like to do is I like to put in my second bracket first, which is f of x. And of course, f of x is just the equation that you're given. So all I'm doing right here is plugging in my 2x squared minus 5x plus 6. But on the left side, I have to calculate f of x plus h. So what that means is anytime you see x in the equation that you're given, you have to replace it with x plus h. So this is going to look like this. 2, and in place of x, I have to write x plus h. So it's 2x squared is now 2x plus h squared minus 5x plus h plus 6. So it's the same equation that's on the right, except that in place of the x's, you're going to put in x plus h. Then we have to do a whole bunch of algebra to try to simplify the numerator. But of course, okay, we have to keep writing the limit as h approaches 0, as painful as that is. And perhaps I may skip some steps here. You may want to do some extra algebra steps to do these. Okay, but if you were to take your x plus h and times it by itself, do the distributive property, and then multiply by 2, you're going to wind up with, well, hey, let me not do too many steps together here. But you would wind up with something like this if you took x plus h and times it by itself twice. And then here, okay, what I can do is I can multiply the minus 5 by everything. So I get something like this, plus 6. And then in the second bracket, all I'm doing is distributing that minus sign throughout all three terms. So I should have minus 2x squared plus 5x minus 6. So let me continue. Writing limit as h approaches 0. I can multiply the 2 through that bracket. So I get 2x squared plus 4xh plus 2h squared minus 5x minus 5h, and so on. And then what you're going to find, and this happens a lot, is you're going to see some things that cancel out. And of course, that's all over h. But notice here, okay, we have a 2x squared and a minus 2x squared. They cancel one another out. We have a minus 5x and a plus 5x, also cancel. plus 6, and minus 6. So you can see that this is going to get a little bit simpler. So this is going to work out to be the limit as h approaches 0 of 4xh plus 2h squared minus 5h over h. So it gets messier and then usually gets simpler. And then in this case, okay, we still can't plug in 0 for h, but what we can do is we can factor in h out of the top. So what I can do here is I can say the limit as h approaches 0, factor out that h, and I have 4x plus 2h minus 5 all over h, and they can cancel. And then now I'm just going to bring this back up here. Okay, so I'm just going to continue back up here, and I'm going to say, okay, that brings me to the limit as h approaches 0 of 4x plus 2h minus 5. Now at this point, I can plug in 0 for h. Okay, I can just plug in right here, so I do not have to write limit anymore. I'm just plugging in a 0. Won't get an undefined answer. Okay, this will work out to just be 4x minus 5. So we have calculated the derivative. I'm just going to use the correct notation here. Because I found a derivative of f of x, I really have the following. I have f prime of x is equal to 4x minus 5, and we just calculated the equation of the derivative. Now, what this means in terms of rates of change and things of that nature, we're going to see over the course of the next few weeks. Let's just stick with just the algebra for right now.